Hey everyone, welcome back to GraphQL Radio. This is the show where we invite experts to discuss all things GraphQL. I'm your host, Abi Iyer, along with my co-host,
Johannes Schickling.
Welcome. Before we begin today's show, I just want to announce that we are available on iTunes, YouTube, SoundCloud, and you can find out more on GraphQLradio.com. So today's show is pretty special. We have a special treat for all the GraphQL enthusiasts out there. And I love our star-studded panel that we have. Gentlemen, can you please introduce yourselves? Start with Joe.
Yes, my name is Joseph Savona, and I work on Relay at Facebook.
Awesome. Lee?
Hi, my name is Lee Byron, and I was one of the original creators of GraphQL and continue to work on it at Facebook.
Great. We also have the Apollo team, two core members of the Apollo team here. Sashko?
Hey, yeah, I'm Sashko. Jonas and I were both founding members of the Apollo project, and I'm leading the team now, and I've written a couple lines of code in Apollo Client.
Yeah, and since Sashko is leading now, so I'm Jonas Helfer, and I'm basically writing the code, managing contributions, and all of that for Apollo Client and the other Apollo projects.
Awesome. So we have both of the big GraphQL clients on the show today. We have representatives from Relay, we have representatives from Apollo. And before we get into these technical details, we'd like to understand the project's motivations and goals. And I'd like to start with the Relay team, and then we'll talk about Apollo right after. Joe, could you lead that discussion?
Sure, yeah. So our goal with Relay is basically, it's sort of we started off with native GraphQL clients for our iOS and Android apps, and kind of iterated over time on this idea of basically JavaScript routing and how to make data available for route as you transition to it. And that kind of grew from a routing solution into, hey, what if we pulled in GraphQL to this into a GraphQL client? And so really over time, Relay has morphed from this originally thing that was really about routing into just a kind of core vanilla GraphQL client, as well as a React integration layer. So our kind of the kind of core use case that we're trying to solve is to make it really easy to write React components at Facebook that fetch data with GraphQL. And so the kind of things that were like the big things that we're worried about there or not worried about, but focused on our performance and making sure that the application is really as fast as it can be. And also just making it simple and predictable for developers to use. And then kind of with Relay Modern, we've been really focusing on performance, simplicity, and then trying to make the system a bit more extensible. But our kind of core use case is really focusing on the hard technical problems that we have at Facebook and then making our solutions that available to the community as well.
Interesting.
Right, fantastic. So, Sashko and Jonas, so when we look back a bit more than a year ago, there was already Relay, and no matter what you guys decided, there should be another GraphQL client. So what were your ideas behind that? Where did you see kind of like the space for that? What were your ambitions and your goals for that?
Yeah, so I think it's interesting to see that Relay maybe started out as a solution for routing. You can see it a little bit in Relay Classic design. Our goal mostly was to create something that would be super flexible and unopinionated. So basically, we were starting from the idea that GraphQL, both the schema and the query language, give you a lot of information to work with to help remove a lot of the boilerplate and work people have to do today to fetch data in their apps, right? Whether that's using Redux or it's using Angular services or something else, because everyone's API is so different, you have to write all this custom code. And GraphQL gave you the opportunity to make a more uniform API for everyone, where you could just have a library that manages most of that stuff for you. So some of the things we're focused on are being as compatible and flexible as possible, so you can use it with tools like Redux, other tools in the React ecosystem like Webpack, Next.js, and stuff like that. We want to make more advanced data loading features that people usually don't get to in their apps a lot easier, like managing loading states, doing offline, doing real-time data. And one thing we realized really early on is that we wouldn't be able to just if we thought really hard by ourselves, we wouldn't be able to look ahead to all the things that people are going to need. And so we focused really hard on making it so that people can kind of own the solution themselves. So all the organizations that we're partnering with, like Airbnb and Shopify and people like that, and New York Times, they can feel ownership over the core and also their parts of the project to make sure that even though they're based on the same technical foundation, they can get exactly what they want. And so when we get into some of the parts later about core GraphQL concepts, I'm going to spend a lot of time talking about how you can pick between one or the other, like pre-compiling queries or compiling to runtime, etc.
Awesome. Before we get into the deep stuff now, like we've thrown out this word GraphQL Client, right? And for the listeners, we should give everybody an overview of what a GraphQL Client is, right? A GraphQL Client does several things. Lee, could you kind of explain to the audience like what a GraphQL Client actually is?
Yeah, I think that's a great question, and it's a really common point of confusion. So GraphQL itself is really a server-side technology. It's an API technology, right? And so oftentimes when I talk to people who are just learning GraphQL and trying to understand all of the different components of it, they think, maybe this is a little too complicated for my app. I have a relatively simple app. I don't know if I want to bring in a lot of new extra pieces. And I have to remind them that, GraphQL in isolation, or GraphQL on its own at least, is really just about exposing data from a server. And so if you have fetch or curl or any way of loading a URL, you can use GraphQL. But when we start talking about GraphQL clients, what we're talking about is all of the parts of creating a client-side infrastructure that takes that data and makes it available in different ways, manages the network for you so you're not actually running those fetch or curl requests yourself, maintains a cache so that data that you loaded earlier that you then go back to the same screen, you're not having to go back to the network, you can pull that right from cache. And if two data loads kind of overlap with each other in some way, that you're making sure that the newer load influences the data available in the cache for the previous load. So it's actually, we're usually building very sophisticated caches when we do this, not just a simple, keep the response that you got for that URL and then return it again. So all of these things, they don't have clear and simple answers. And in fact, every time that we build an application, we need slightly different things from all of these different parts. Different ways to talk to the network, different ways of managing a cache, different ways of building our application on top of those pieces. So this is why we have both Relay and Apollo as two different ways of building a GraphQL cache for JavaScript, but also when we get to native clients like iOS or Android, we tend to see a lot of variation there as well for building these kinds of things.
I just have one point to add here, which is why a GraphQL client in particular. And I think one small point I've kind of identified is why it's so much better to build a GraphQL client library than some other client library is because GraphQL works equally well as a query language to read from your server as it does to read from a client-side cache. So when you're caching data with Redux, the way you talk to the server is through a request, and the way you talk to your store is through a JavaScript selector. But in both Relay and Apollo, the way you talk to your server is with GraphQL queries, and the way you talk to your cache is through those same GraphQL queries. And that's why it can help you reduce so much of the boilerplate.
Yeah, not to mention that it's consistent amongst projects too, right? These selectors that we write as UI developers change constantly between projects. Arrow body or no arrow body, whatever, Right. So
that's a super interesting concept. So Lee or Joe, did you also kind of explore this idea of reading from a local cache with GraphQL itself, or maybe you can give a bit of a better picture of what makes the relay cache, and maybe Sashko, maybe you want to elaborate a bit more afterwards how that's similar or different in Apollo.
Yeah, so this is definitely, as Sashko mentioned, the kind of uniformity of just being able to express a fragment. It's sort of kind of in a way, I think in the Redux community, it's sort of a best practice to normalize your data across different types, and then based on within types by ID. And probably a lot of what you're doing in the selector is then saying, okay, now we've got this normalized data. Let's go and pull pieces out from all the normalized bits of the Redux store back into some view. And really, that's kind of replicating the work that the Relay and Apollo cache are actually doing, which is handling that normalization for you. A GraphQL fragment is sort of saying how to take a normalized a normalized set of data and put it back into denormalized, convenient form to use for a UI component. So that's definitely something that I think is just a very powerful concept. So the nice thing is the way we've structured Relay, and Sashko can speak to Apollo, but is that the kind of core runtime is actually to a degree GraphQL agnostic, in the sense that it's a cache of data. We use GraphQL objects as a way to put data into that cache and take data back out of that cache. But it's it's agnostic of the actual schema. It's agnostic of the server. It's really, here's a payload, here's a GraphQL fragment, write this into the store. Here's a fragment in a store, give me the data for this. And so theoretically, if you could have fragments that are compiled against a purely local schema and never even talk to a GraphQL server and still get the benefits of that normalized cache. So by just making the system modular, we can say, okay, here are these components that you can put together in different ways and use it for those use cases.
Awesome. Let's bring it over to the Apollo team. Hey, Jonas, could you explain the GraphQL client and the normalized cache for Apollo?
Yeah, so I think now with Relay Modern, actually, Apollo and Relay work in very similar ways. So the basic concept is that Apollo client gives you a way to query data, and that's just a GraphQL interface. So you can do a query, you can do a mutation, or you can do a subscription. And all of these are just GraphQL operations. And what at least the sort of the one-time operations like queries and mutations will do, well, no, just queries actually, is you give that to the client, and the client will go and try to reassemble all the data that it needs to respond to that query from the cache. Now, because we have GraphQL, we actually know what the path is for each of these objects. So we can actually know when we already have the entire query in the cache, even if that exact query has never been issued before. So we'll go and we'll check in the cache, and depending on sort of what the client specifies, we'll fulfill that query from the cache directly, or we'll send it to the server. Now, in Apollo client, all these parts are pretty independent, and I think this is similar to what Joe described for Relay. So in Apollo, we have this thing that we call the core, and then we have a store, and we have a network interface. And what the core does is basically just, kind of relaying between the cache and the network interface. So when the query is not in the cache, it will be sent to the network interface. We'll fetch it from the server. We'll write it back into the cache, and then we'll send the result back out. And as we normalize data into the cache, if there's any other queries that were watching the cache previously and whose data was touched, we'll also notify the components that were watching this query. And that way your whole UI basically stays consistent.
Right. That makes a lot of sense. So how would you, recapping what we've just learned about the Apollo cache and the Relay cache, how would you say where's the biggest difference between Relay's implementation and Apollo's implementation, which is more, so Apollo always speaks about that it's very, very open and easier for people to contribute. Does that, on the other side, mean that Relay's cache implementation is a bit harder to grasp and to get into? So what are kind of like the what makes it appealing to work on with the Apollo cache versus the Relay cache? Maybe Sashko or Jonas, maybe you want to go first? And
I think this is definitely a little bit different now. I haven't actually looked yet in too much depth, but my understanding is one of the differences between Relay Classic and Relay Modern is a simpler cache implementation. One of the things that we really wanted to nail with Apollo, and one of the reasons we built it back in the day to start with, was we really wanted to make the cache something you can look at and touch and feel directly. We actually haven't changed the cache format at all since, very, very small things about like JSON scalars and stuff. But you can go ahead and write your own custom Redux reducer, copy and paste code out of Apollo to modify that cache in whatever way you want, and it's just a plain JSON object. And that's one of the properties we really wanted to maintain, because when you looked at the Relay Classic cache, and I don't know exactly if it's different today, there's a lot of fancy objects with prototypes. There are some nested structures to handle connections that weren't always easy to extend. But from my understanding is that the newer cache structure for Relay Modern is much more extensible. Although I don't know if it's quite all the way to where you would want to pull out a JSON object and operate on that directly. Although I know there are also facilities to do that with these proxy objects that you guys have.
So with Relay, our kind of primary goals is really around performance, and so we really looked at different ways of making it as fast, as efficient as possible. We kind of didn't want to introduce extra overhead into the process. And again, so I think it's kind of comes down to focusing on flexibility versus focusing on more on the pure performance case, and then that kind of leads to different trade-offs. So with Relay Modern, we basically said, okay, let's take all of the connections, really the kind of prototypes and custom classes that we had in the store were all around connections. And our goal going in was to say, okay, what if we take out the notion of connections from the core and make this something that you can implement in user space? And so we managed to achieve that with Relay Modern. So the cache is just basically plain JSON objects. It's structured in such a way that you don't get to assume that they are just plain JavaScript objects. Basically, we want to kind of preserve the ability to do object.create null, possibly, or use a JS map, or some other, or possibly even a custom list implementation, whatever we want to do later. But the basic idea is that it's a simple, straightforward implementation that is pretty easy to JSON inspect, and to serialize and deserialize without having these custom class instances in there. As far as the kind of extensibility versus performance kind of characteristic, so I think one of the key things is we're kind of assuming that you're putting a lot of your data into Relay, that you may be using Redux on the side for some amount of things, but what we've seen is that once you start using Relay, a lot of your data ends up being in Relay, and Redux becomes a more supplementary data source. And if that's the case, then we want to optimize for the majority of your data and not the minority of your data. And so, for example, going through the Redux overhead and being able to kind of control at a fine-grained level when we update the store, when we actually notify views, and having kind of more control over when those discrete actions happen has been really important for us. At the same time, that means you don't get the easy integration with Redux that you have with Apollo.
Yeah, I mean, in both clients are trying to achieve a very important feature for modern front ends. But as we all know, caches become inconsistent and they become stale. I'd really like to dive into the challenges of building a cache and keeping it consistent. And I'd actually like to start with the Relay team. Either Lee or Joe, please take it away.
Yes, happy to answer that one. So I think this is something that I think is kind of people who are used to working in a REST system, or maybe just haven't. It's something you don't get exposed to necessarily, but once you attempt to have a normalized set of objects that basically a graph that you then normalize into a cache, there's some kind of weird edge cases that can pop up. So for example, a user has a best friend, and you fetch the best friend's name and their age, and then later on the user changes their best friend and you only fetch the name. And so now we're missing the best friend's age. It's just not available on the client anymore. And so if you attempt to achieve perfect consistency, now you're in this case where, okay, we've achieved consistency. We know that the best friend changed, but we're also missing some data. And so there's this trade-off around consistency versus completeness of information. The same thing can happen with lists. That's their perfect example of somebody adds a new item to a list. So a list of stories, somebody adds a new story, they add with certain properties, and you are observing that list and you care about more properties than were added. And so now you're missing some properties on the new item. So these are kind of some of the challenges that we run into, and that, we just have to kind of find solutions for. And so our solutions are largely, I think the main one with Relay Modern is sort of partial consistency, particularly around lists, where we keep different kind of versions of a list in order to isolate you from that new item with missing information case.
I think, I don't know, Jonas, I don't know if you want to talk about how we did it in Apollo, or maybe I can talk.
Yeah, no, I was just going to say that's actually an interesting approach, because you probably then end up in the case where now you have two lists that are the same list with different items, right? So it's kind of a trade-off. Is like, would you rather have both like two same lists that have like items that have some properties that are missing, or would you rather have two different lists so that like all the properties are in all the objects? I would say though, actually I think for most people, or at least for most users, we've seen like those are the cases they run into only after a while, and the normalization already gets you like a really, really long way to keeping your UI consistent, because there are many cases where you like have overlapping queries and you do actually, like ask for the same data. And in that case, what a GraphQL client can do for you is it can automatically keep your UI consistent. And with REST, that's a lot more difficult. And I see a lot of people kind of like rolling their own solutions for this. And that's really like thanks to the query language and sort of the types that GraphQL exposes, you can actually keep your UI consistent to a much larger extent than you were able to before, without having to go into cases where you say like, okay, now we've actually done this mutation and we've inserted this object on the client, but we only asked for some fields, and there's another query that's watching the same data and it asked for more fields. What do we do? In Apollo Client, we actually, so there's two ways of dealing with this. One way is basically to say, well, okay, this query used to render just fine. Now there's this new item there and it doesn't have all the data. Now rather than like throwing an error or something, we'll serve you stale data. So we basically do the same thing that Relay Modern does, I think, as Joe described. The other option is that we detect this case and we actually refetch the previous query. And I think it should be up to the user to kind of decide what they want to do, because in some cases refetching can be expensive. They might not want it. They might not even care about the data being super up to date. But in other cases, it's like really important that these two views are consistent. But yeah, there's like a whole rabbit hole. There's a rabbit hole that you can go down there, because if your data on the server changes frequently enough, you might be refetching over here, and there's already new data, and now you don't have complete data for this other view, and then this one refetches, and then it just keeps going back and forth. So you kind of need ways to break that loop.
This is also, we're talking about edge cases here. We were talking before about like why should we think about having a GraphQL client. We really quickly we got into the weeds of all the edge cases that a GraphQL client helps solve, or at least quickly highlights. As soon as you get lots of people using these frameworks, we start to find all these edge and corner cases, and that we spend a lot of time and attention thinking about. But I think it is important to note that these are edge cases. But Jonas, I really liked your point that as soon as you reach one of these edge cases, the whole reason that it's difficult is that there is no right answer. And giving people control over what to do is really important. And I think this was one of the lessons that we learned with the previous version of Relay actually a long time ago. And even before that version of Relay was open sourced, we had found and fixed some of those by issuing new API methods. And with Relay Modern, we made sure to do this correctly from the start, which is basically as soon as you bump up against something where the way that you treat the network or the way that you resolve one of these conflicts in the cache it's not an infrastructure problem, it's a product problem, right? The way that you solve this is very much to do with the way that your product should work and not something that can be solved generically. We'll try to come up with the most reasonable defaults, but at the end of the day, it's really important that both of these libraries, and they both do, give you the right APIs to take the gloves off and manage the network yourself when the time comes.
One thing I think is really cool to highlight is exactly why GraphQL is the best way to solve this particular problem. Because can you imagine having a situation where you have two different REST endpoints that return lists of the same kinds of items but with different fields in the result? Like, you're never going to figure it out. But the main reason why Apollo and probably Relay as well can figure out that the situation is even happening is because you have to declare the fields you're asking for. So you can know if there's a query over here and a query over there, and this one needs more fields, you can determine that at runtime, at build time, and actually identify the case when you should serve stale data. Because I can't imagine how somebody using Redux in like a pretty standard way would determine the fact that they have now incorporated into their cache these like overlapping sets of data, and I imagine most people will probably just end up with like missing fields or like some other runtime error.
Yeah, these are totally common bugs that you'll find in lots of apps. And now that we kind of have seen where they come from, It's pretty clear why we see these kinds of bugs in apps all the time. It's the edge case that people run into, and it's really hard to detect until it's too late.
So we've spoken a lot about the cache now, but I think there are also a lot of other aspects to a GraphQL client. So one of that, what I have in mind, is how you construct these out of these fragments that are bound maybe to a view. How do you construct the GraphQL queries? How is that, for example, solved in Relay? And what is Apollo's take on that? And that also kind of leads to how is that integrated with a view layer such as React or Angular, for example. So maybe Joe, you want to start on this. What is Relay's take, and both Relay Classic and Relay Modern, how a query is being constructed?
Yeah. So the basic kind of one thing that sort of hasn't changed between Relay Classic and Relay Modern is that we want to take advantage of the schema as much as possible. The schema gives us a lot of information, about how the app can work. So a simple example for where this kind of comes into play is somebody does a ... on user, and they select some fields on user. Now the question is, do I provide those fields to you or not? Like, does the actual record, is it a user? Does it match that type? Do I give you those fields or not? A simple example of like where that actually comes into play in an application. And so we wanted to use the schema to kind of help us optimize the app, make it work better. For example, is there an ID field? Like, can we fetch the ID? Should we fetch type name? Or can we? Can that be statically known? So with Relay Classic, we basically we had a Babel plugin that transforms the query into a runtime artifact that kind of encodes the sort of minimal bits of the schema that you need to understand that particular query or fragment. But each query was sort of translated in isolation, and then we'd stitch them together at runtime, do a traversal over the AST, and then print that back into a GraphQL string, send it to the server, traverse the query and the response together, write the store, etc. With Relay Modern, we basically said, okay, this static, optimization pass on queries is really valuable, but we can take it further. So rather than do individual just analyzing fragments and queries in isolation, we basically do whole program analysis. And so we can say this query includes this fragment, so we can actually optimize the query artifact to sort of inline portions of the fragment, fetch the ID field or type name field only when it's strictly necessary. These types of optimizations, and then generate artifacts that are used at runtime. So it's similar to Relay Classic in that we still have an artifact per fragment, but one of the big differences is that we know the full text of the query ahead of time at build time. And so we're not doing this traversal over an AST and printing it to a string at runtime, which we found could be slow, especially on older mobile phones.
And I think you're maybe even underselling it. Like this is like the biggest change between Relay Classic and Relay Modern is that we can know any query that the client can send, we know what they will be ahead of time. And I think the most important trick that this lets us do is persist our queries at compile time. And this is a trick that we've been doing at Facebook for years now on our iOS and Android devices, but hadn't done in our JavaScript clients yet. And Relay Modern gave us the ability to do it. And the basic idea is that because we can do whole program analysis, we can deduce exactly the sets of queries that client could send. What we do is we save them on the server, and then we get an identifier that refers to that query on the server. And that's actually what we ship with the client. So the client doesn't actually even need the information to build a query string itself. All it needs is that one identifier. And then at runtime, when it actually needs to send off one of these queries, it can send off this really tiny identifier that it has, just in a const somewhere, rather than having to first actually walk all the artifacts and build a query string, and then second, send that whole query string, which for a complicated app could actually be fairly sizable. And upload bytes are much more expensive than download bytes when we're talking about mobile networks. So that all adds up really quickly to be the most expensive part of the entire exchange on the network side. So we learned these lessons on iOS and Android a long time ago, and wanting that specific feature was like the primary motivation for the whole idea of going back to the drawing board and re-architecting Relay.
Yep. So yeah, as you mentioned, that's it was really all about, okay, how do we enable persisted queries in Relay Modern, and that was the kind of the fundamental basis for us building the Relay compiler to do this whole program analysis. And one of the things that came out of that, though, is once we had the knowledge of what the query structure was at build time, we could say, wait a minute, we're going to process result. We're going to use these artifacts to process the query results we get back from the server. Can we make that? Can we do more analysis at build time to make that process faster? And so we have a bunch of optimization passes in the compiler. So, for example, if you're fetching a bunch of information about a user, like user's name and ID, and then you do ... some fragment, and that fragment also fetches ID and name. Well, we know that we don't have to process ID and name twice. We can just inline those. And so we can basically eliminate a lot of redundant work that we would do in processing the result. And so we saw in a benchmark, kind of taking an example query from one of our apps, and just doing with example data, we saw that processing that went down. Processing the query results got about 10 times faster. Again, this is in a benchmark based on real world use cases, but running in a benchmark, but still kind of an example of how that optimization can play out in the real world.
So Sashko and Jonas, is that like an optimization you also have in mind for Apollo? Since I think this is also that you don't need the step can also be a strength for people getting started more quickly, that you don't need this Babel compile step. So what is Apollo's step? What is Apollo's take on this?
I'm really excited. I think this is really hitting at the most. I've been thinking recently. I'm like, what are the most important differences, right, between Relay and Apollo? One for us is definitely the community aspect of it, but I think this is probably the biggest technical difference. Is at least back when I was working on it, what I was thinking about when I was thinking about Apollo is that it's like a fancy implementation of fetch. And what that means is it's completely agnostic to where you got the query, what the query looks like, who generated it, how it was composed for fragments, whether or not it was compiled, whether you have the text or the AST, anything of that nature. And that's the main thing. So one trick that I've really wanted to pull, if you can call it a trick, is actually running the Relay compiler and passing the result straight into the Apollo core, because I think that would actually just work. Because we've taken the input to both the higher order component with the GraphQL query and the core of Apollo as like a totally separate concern. People in the community have actually built a plethora of various build tools, analysis steps, Webpack plugins, all kinds of stuff. And then at the end of the day, you just take the output of that, which is just a GraphQL AST, which looks pretty similar to the generated output from the Relay compiler, and you just put that right into the client and you're good to go. So what that means is people in the community have built, basically what that means is you write your queries in whatever way you feel is best. We don't specify that, but you can achieve almost any trade-off that you want. So we have a mode where everything is fully static and you can run persisted queries on it, associate all the queries at build time and create them into artifacts, just like you heard about before. But we also have a way to do it in a completely dynamic way. Like you can string interpolate your way to whatever query you want, and at the end of the day, just parse that and pass it in, and that will also work. And I think we've gotten a lot of mileage out of that approach of taking the whole compiler aspect of it and just removing it from the picture of Apollo entirely and letting people in the community build any sets of stuff that they want. So I'm really excited to explore dynamic ways of generating queries, like taking some of the stuff people liked about Relay Classic and seeing if that would be something we could reproduce, or taking the Relay compiler as is and just seeing what happens if we could run it and have all the optimizations around fragments and stuff, and just have that work with Apollo as well. I think that's kind of exactly the thing that we've been working towards, is a system where you can just take that entire part and just abstract it away into anything that people want to do with it.
I think that point for Apollo really helped a lot of newbies get into GraphQL, right? Not having to deal with the compiler stuff like that. And, libraries like GraphQL tag make it even easier to start using a GraphQL client such as Apollo.
So some of the most popular things people are doing right now are, for example, pre-processing their queries with a Webpack loader. So you do the parsing step ahead of time, and we don't yet have the ability to inject schema information into there with that specific loader, but that would be a cool thing. Then we have this runtime parsing thing, and we have the persistent queries thing, and then there are also people who are building frameworks. So 2 particular examples are Vulkan, which is this thing that Sasha Grafe is building, and also the Coral project from Mozilla. They're both doing this thing where they kind of just abstract the concept of queries entirely from the user and generate them entirely dynamically, and then they just pass that into Apollo and like it handles it. I don't know if that's necessarily the best way to go if you're not trying to build like a CMS. You probably do want to go with static queries, but it's great that that's also possible.
One important thing that both these GraphQL clients offer are view layer integrations. And I know from just being in the Apollo community that Apollo's goal was to support any view layer or many view layers or all of them, right? And that's through the community contributions. Could you guys explain the view layers that you guys currently are maybe promoting or really stand by? And can you guys understand, could you guys let the audience understand what that connection between the Apollo client and a view layer actually is?
Yeah, so I think the approach is a little bit different here as well. So I've read that, well, not only read, but experienced that the Relay core, I guess I'm not sure exactly what you guys call it, like Relay environment maybe is the name for it, is now totally separate from the React Relay React integration. So I think it's great that people will now definitely be able to build adapters between the Relay environment and also other view layers. For us, the biggest one is by far React, because there's such a strong association between React and GraphQL. Most of the time you hear talks about GraphQL, at least back in the day, it was at React conferences. So React is definitely our main focus. But there's also integrations for Angular. You're not allowed to call it Angular 2 anymore. It's just Angular now. I saw somebody recently give a talk. There's a totally community developed integration for Vue.js as well. And there's also even people who are... Yeah, Ember. Ember is another big one. Oh man, now I'm gonna get nailed if I don't mention all of them.
All. Yeah.
But there's also people using it with like jQuery and Backbone and like stuff like that, and that's also really cool. And I think that really like, well, it's not really like an advantage of Apollo right now on a technical level anymore. It's just the advantage right now that we had that before, so there are all these integrations already in existence. But I'm really excited to see these also come out for the Relay environment.
Yeah, I think one thing that's useful to mention here is that an Apollo client or an Apollo core, what we really do is we actually try to provide all the abstractions that you need to easily be able to build a view layer integration. And one of the things that you often want to do in a view layer integration is you want to get a synchronous result, or at least you want to get information about like, do I have this in the cache, or is it like still loading? Is a network request in flight, or was there an error? And we initially did not have these things in Apollo core, and then we noticed that all the view layer integrations were essentially building the same functionality. And there are like subtle corner cases where you can get things wrong, because you have to like, for example, you want to keep track of the previous result that you had, and you want to give the previous result if there's no new result, if you just updated the variables or the props for one of your components. But there are some cases where you update the props and you actually don't want the previous result and stuff like that. And we noticed that those were actually the same across pretty much all view layer integrations. So what we decided to do is we decided to pull this not directly into core, but into like essentially a view layer integration that lives like really, or that comes shipped with Apollo client if you want that, just to make it easier to build those kinds of integrations.
Yeah, essentially what Jonas is talking about is we have a concept called like, I guess observable query is what it's currently called. And that kind of has its own idea of like some props and some output and like a current state. So when you look at React Apollo, basically what it just does is it takes the props and passes into that thing, and then takes whatever result that thing gives you and just passes it into the component. And that makes it easier for people to integrate with new stuff.
Yeah, so this is a change that we made in Relay Modern. The previous version of Relay was very tied to React. And that was because at Facebook, we use React to build stuff. And we built Relay long before we had any plans to open source it as a tool for Facebook to build stuff. So it was pretty natural that it would be tied specifically to React. And the shift to make the individual pieces more reusable so that you could build different view layers on top of it was in large parts driven by requests in the community, seeing it successful with the Apollo client, and people saying like, I love Relay with React, but this other app I'm using over here is a different view layer. Can I bring React, or can I bring Relay with me? And we wanted to make sure that they could do that. But I actually think beyond just enabling that, we were really excited to do that because it was a natural seam of abstraction between the pieces of the software that led us to make better decisions than we had made in the previous version of Relay. So it actually set up better APIs for the core. We call it Relay Runtime, is the piece that's view agnostic. And then React Relay is the React View layer integration that most people use, just the React Relay API, which actually just proxies through a couple of the Relay Runtime APIs directly. And the other thing is that we found that even in the context of a Relay app, there are cases where you want access to that data outside the context of a particular view. So you're working your way through React components all the way down until you get to a particular point where you say, okay, now I need some data to run this utility function or to go do this non-visual thing. How do I do that? And you could do it in some workaround ways with the previous version of Relay, but Relay Modern makes it really easy to just kind of take the gloves off from the UI side of things and immediately start using it in a view agnostic way, even in the context of a React app. So what I'm really excited to see is not just people building different view layer integrations on top of Relay Runtime, but building crossover integrations. So you could have an app that, and this has actually been really important for us on the React side of things, is making sure that if you have an existing Angular app or anything, and you want to just take a small part of it and use React there, that should be a completely reasonable thing to do. You shouldn't have to totally rebuild your existing app and use React everywhere. It should be absolutely okay to use it only in an isolated part. And so if you want to use Relay, we want to make sure that it's really easy to use it in a way that doesn't just work with one UI layer at a time, but works across all of them in concert with each other at the same time. So that's a thing that we foresee happening from the community's point of view. We're probably not going to be the one to build all the different integrations between all those different view layers because, of course, our focus is making stuff work at Facebook and we're using React. But that was an exciting thing for us to be able to set it up so that people could do that.
Right. I think that's a super interesting point. So one thing. So since you started out first with React, and one of the things that sold me so much on GraphQL in the beginning, when people were still thinking Relay and GraphQL was more or less the same thing, but one concept that really hooked me was that of a query collocation. And the fact that you used React and Relay at the same time, you were forced into this way of thinking about components and how can you co-locate your data dependencies. So I think that you use this together kind of drove that design. Maybe I'm wrong, but this made a lot of sense for me. But at the same time, I think now that you refactored all of this out, would you say that it's that you've now ended up with a better design overall?
Absolutely, yeah. The design is much better, and this is, I would say, not unique to Relay. This happens whenever we open source anything. It's actually one of the primary reasons why we open source our software. Is Facebook's code base looks like one giant application most of the time. Everything can touch everything else. Our product from the ground up is made to be tightly integrated. Every part of the product touches every other part of the product. And when it comes time for us to take some of the software that we wrote to make that possible and make it reusable, it forces us to think about the seams of abstractions between these pieces in a new light, where we used to kind of have those shaking around the back of our head. We'd do our best to make sure that we were writing well-reasoned abstractions with reusable code, but not until you have to take it out of the code base, put it in its own GitHub repository, and then rely on it via the open source channel, do you realize just how many small Facebook product-specific things are still left hanging around? And open sourcing is a forcing function for us to think really hard about exactly what those API seams are, and it always ends up leading to better designed software. So our team, product infrastructure, which is responsible for Relay, GraphQL, React, Flow, Jest, and a handful of other projects that have all They're all critical to building the Facebook product. They're all also open source. We do that on purpose because it makes sure that the software that we're building ends up being very well designed.
Yeah, I just wanted to point out, if you don't mind me going back briefly, we've already seen people from the community, people who've been involved in Relay, since the beginning of the classic version, kind of taking advantage of that architecture. Already starting to work on server-side rendering for Relay Modern, offline caching for Relay Modern, things like that. And I think that's kind of a good early indication that we kind of did get that like API boundary clear and kind of expose the right primitives. And one thing kind of going like that, part of getting that right was we're focused on runtime performance in terms of CPU usage, but we're also looking at memory usage. And I think this is kind of something that has come up as we've talked to other companies that are building larger apps that really can fetch large amounts of data. And that we kind of found with Relay Classic that we tried to integrate some forms of garbage collection and cache eviction, but that it was kind of hard to add on later. And going back to the drawing board, give us a chance to integrate that at the beginning and to kind of build, again, like these core primitives that support the memory management use case in. And that way, when you're looking at these like core primitives, it's all kind of designed to give you that control of the memory usage from the beginning and build abstractions that like play nicely with that. And so again, like it's kind of important to have that. Like if it's not, that was one of those things where if it's not in the core, we found it very hard to add on later. And so, I think we're pretty pleased with that, with the way that was able to work out and kind of fit nicely into things.
It's really interesting that you guys kind of consider the cache to be part of the core, because one of the things that we're working on right now with Apollo Client is to actually take the cache out of the core and make that API actually a public API, so people can plug in whatever store they want and do persistent caching.
Yeah, it's a public interface in Relay Modern as well. For exactly that reason. So we have basically when you create an instance of an environment, you're basically passing in the actual cache object that conforms to an interface, and for exactly that reason of giving people control over how that's implemented.
Okay, yeah, that makes a lot of sense.
Yeah, so look, one of our goals with Relay Modern was to kind of break it down and kind of have, if you look, almost all the functions are actually accepting objects of an interface. And we have default implementations of those interfaces, but then you're able to then say, actually, I want to implement that differently. And so, for example, we have the store. We have a default implementation of the store that does do garbage collection, but you could pass in an implementation that doesn't, and because you just don't care about you just don't want to have that overhead. So yeah, it's definitely good to kind of give people the flexibility to kind of tweak things when they need it, but also have like a default setup that just works out of the box.
Yeah, I think it's really exciting that the two clients kind of and our approaches are really converging in many ways. So I think just like Sashko mentioned before, that maybe with a few tweaks, basically the output from Relay compiler could be passed into Apollo Client core and it would just work, right? And so I'm actually excited to see if what possibilities there are to kind of mix and match the different parts.
I could imagine powering the Apollo public API via Relay core.
Yeah, could happen. Could happen the other way around as well.
Yeah. Sure. I think there's a lot of room to explore. There's so much similarity that I don't know which layering makes sense, but there's kind of a clear bottom up of we're both doing this taking text and converting it into an AST, and I think there's kind of room to kind of from the bottom up say, okay, what are the commonalities, and also from the top, what are the view layers doing, and if it's similar enough, maybe they could be shared and have the runtime be, or at least a layer around Apollo runtime that allowed you to. I think there's kind of room at the I don't know if the actual core, there's probably some different assumptions there. We talked about garbage collection, connections and pagination. There's some different things there, but the kind of compiler, like you talked about, and maybe the view layers is another area where we could maybe kind of converge over time.
Yeah, well, one of the things I definitely want to highlight is that it's not a coincidence, and it's not an accident. It's because that we're always talking all the time. I think it's something that people don't really see, but I think we're trying to do a better job of calling this out in some of our newer posts, like in the post about persisted queries and Apollo Client and stuff. We definitely called that out, and is that a lot of the ideas that we have are just hijacked from talking to people who have worked on the Facebook native GraphQL clients, for example, or ideas that you guys have had but didn't have time to implement. Hopefully a little bit the other way around is basically we're all here kind of trying to converge on the best developer experience. And while there are some fundamentally different opinions and goals, at the end of the day, with some things, there's just like one best way to do it. And if both or all of the options are converging on that one best way, that's great, because it means people have to learn less stuff when they're trying to switch technologies.
I agree. It's super exciting. And I actually see it as kind of a bigger version of something that's been happening within Facebook over the years as well, is that our various iOS, Android, and JavaScript teams in the earlier days of GraphQL had really different ideas of how to solve these problems. And over the years, we've tried to, by trial and fire, figured out which ones worked and which ones didn't work and why. And it's never super clear. It's always like, oh, this one has the edge on this thing, but a downside here, and this one's the opposite. And so over the years, we've tried to learn from all of our different implementations, which aren't that many, right? Like we're still just kind of building the same app in a handful of different environments, and borrow the things that worked for the next versions of the frameworks that we build. And that's how we land on this idea that persistent queries are key, and we need to make sure they're enabled everywhere, which helped motivate this newer version of Relay. And
yeah, what's really funny is we had a similar story where we're building this product, Apollo Optics, which lets you like log your GraphQL queries, and we have a sidebar in there, and the sidebar shows your query operation name. And then we were like, oh crap! Like if you use Relay Classic with this, the operation name doesn't actually tell you what's going on in the query, so we can't actually use that information to name the query in the sidebar. And we were like, man, we really got to get everyone to like use static queries so that they can get better logging in their server. So it's actually like the same reason.
We have the exact same thing. Like we've been using static. That's one of the same benefits we have from having pre-compiled static queries in our native apps, is we get lots of really useful analytics about how our native apps are using data that we just didn't get the same granularity from our Relay apps, and we wanted that too. There's so many great benefits to having the static queries that it was just clear to us over time of playing with these different approaches that there are always trade-offs, but the costs of having these statically known queries were just completely overwhelmingly worth the benefits that we got. So, of course, we've tried to like sing from the rooftops whenever we come up with one of these ideas. It seems to work universally well across all of our clients. And sometimes we've been, happily surprised to see folks outside of Facebook, like Apollo team included, arrive at the same conclusions even before we've had the opportunity to talk about them. That way, when we do get together and talk about these things, we're like, yeah, awesome. I'm glad we didn't have to like dig too deep into this. So like we landed on the same thing. Like, well, let's tell you why we think we're so excited about the direction you're taking it. So that's honestly why I'm so excited that there's lots of different clients out there for the public to use, is that, GraphQL is still not that old, right? Like I'm sure there's more of these ideas where we won't know which ideas are worth their cost and which ones aren't until we trial by fire all of them. And the more clients we can kind of have testing out all these different ideas, the more quickly we can like learn from each other. And as you said, Sashko, we're talking to each other all the time in the GraphQL community and figuring out which of these ideas should succeed.
One thing that I want to add is I think it really speaks to the quality of the GraphQL spec and the GraphQL reference implementation that all of these like tools are really able to work together. Because the main thing that we do in sort of the Apollo ecosystem with all these small libraries that we have is we take the GraphQL AST and the GraphQL schema to sort of be these core concepts that we build everything around. And so even when we built Apollo Client, we briefly thought like, should we have the internal representation of Apollo Client be something other than the GraphQL AST? Surely there are some optimizations we can do. And we thought about it for a moment, but then we realized like, no, really, like if you use the GraphQL AST, this is going to be compatible with what everyone else can build, right? Everyone can see the GraphQL AST. Everyone can easily create an GraphQL AST from the query or from a schema. If that's the thing kind of we operate on, or at least on the external API, if that interface supports the GraphQL AST, then really like you get almost universally compatible libraries in the GraphQL space, and I think that's super valuable. And that's why personally I think it's gonna beat everything that's been there before, like all the REST libraries and everything, just because there's so much value around providing a specification and a standard that everyone can build to.
So speaking of what everybody can build, I'd really love to talk about a bit more about the ecosystem now that Relay is more open. I think there's a lot of room for building tools in the user space. And Sashko, you mentioned that like there are so many things that you'd like to build, but you don't have the time to. And so, Joe, maybe you want to tell us a bit more about what you'd love to see building, what you'd like to, being built on top of Relay, such as routing structures or special tools being built on top of Relay. So what ideas do you have in mind you'd like to see other people build?
Yeah, I mean, it's a great question. There's a bunch of features that we've kind of enabled in Relay, the new Relay Modern Runtime that are sort of not fully documented yet, and so we're definitely working to get the documentation out. But some interesting things are we support live queries. So we basically the Relay runtime sort of assumes that your query can be live. Our baby's in the background, so she says hi. The idea that basically if the server is able to stream back responses over time, that Relay runtime just supports that. So I'm looking forward to kind of seeing the community kind of add network layers and servers that actually support that. Also, obviously, we have the ability to do GraphQL subscriptions. So that was something that people built in user space for Relay Classic, and that now that's largely just available in the framework. But things like you touched on, I know, so Apollo has a great developer tools where you can kind of inspect the state of the store. That's something that could be, pretty easy to build with Relay Modern. Again, because the store format is a lot simpler. Server rendering was something that, again, there's a community project for in Relay Classic, and would love to see that kind of be updated for Relay Modern. Routing is, I think, a really interesting one because there's not a great solution, as far as I can tell, for sort of nested routes where each nested route has its own query dependencies and you want to aggregate those as efficiently as possible. It doesn't really seem like there's a great solution there in the JavaScript space, especially if you want to also do like kind of incremental code loading and data loading together. And again, the fact that we can statically know what the dependencies are for a view seems like it would kind of allow you to build some interesting things. And so I'm really looking forward to seeing people build on top of that. And finally, the last one, sorry to ramble here, but we have support for basically client-only schema extensions. And so theoretically, you could imagine a serverless Relay app where all the data is expressed locally. And so I'm looking forward to seeing what people kind of build on top of those APIs.
That sounds very interesting. So maybe Sashko, maybe Jonas, you have some ideas, since so many tools have already been built on top of Apollo. So where do you see? So I think a lot of these tools can also be maybe compatible between both clients. So what are your thoughts on this?
Yeah, definitely. That's one of the things we've put the most time into and coordinating with people in the community is to get things like server-side rendering, for example, like to feel really, really natural. Like it's just one line of code that you get from the React Apollo core to drop in and server-side render your app. In terms of where we are on the frontier of that stuff, I think we have kind of two main initiatives that also align with what you guys are doing. One is to unify some of our like build and command line tooling. So we have currently a package called Apollo CodeGen, which is primarily used for generating code for our native clients, right? Apollo iOS and Android.
And typings for TypeScript and Flow, right?
That's right, yeah, which also generates typings for TypeScript and Flow. Then we have a separate tool that's a ESLint plugin that lets you see like query errors inside your editor. Then there's like a separate thing, which is like an IntelliJ plugin. Then there's like another thing which does persisted queries. And I think unifying those into something that's kind of like the Apollo equivalent of the Relay compiler tool is something that we're getting some people together to work on. And I think some people from Coursera, for example, were really interested in working on that. So that's one thing that we're really going to get into. And there's definitely some stuff that could be reused there between like the Relay compiler and Apollo CodeGen. One fun thing I learned, sorry, I'm going off on a tangent now. You're never going to be able to end this podcast. One funny thing that I learned recently is that like I think Relay compiler operates in terms of AST transforms on the query. And apparently the way that Apollo CodeGen currently works is it actually runs GraphQL execution on the query and like saves data during that. So I thought that was like a really funny distinction. I want to go learn more about that like over time to see what the pros and cons are, or maybe there's a combination of both or something like that. So that's been pretty interesting. And then the other thing I think is what you also mentioned, which is like live queries. One of the limitations there is for us is the current design we have for the network interface, which is similar to what you guys had for the Relay Classic network interface, where there's like a query thing that returns a promise. So one of the things we want to do really quickly is create a more generic network interface implementation that lets you do more stuff, like unify all the operations into one function. That function maybe returns an observable or something similar. And so people can start to experiment more with live queries as well.
Yeah. So the way we've supported subscriptions in Apollo Client in the last, like, it's probably already, what was it, like 9 months?
Yeah.
Is actually with a kind of separate transport. So if you do a query or a mutation, that will be sent over HTTP, but the subscriptions was sent over WebSockets. But anyway, that's a tangent again.
The ecosystem is growing, extremely fast, especially on both fronts of the clients. And we've been talking about what these clients are today, and Relay Modern just released, or like the RCs. I want to talk about the future of GraphQL, not necessarily the GraphQL clients. Like, we should probably talk about what's coming up and how does that affect your guys' product roadmaps, things like that.
Yeah, I can answer that to a degree. So our goal with the future of GraphQL is to do as much in the open as possible and to go slow enough so that we're never surprising people or moving things along so quickly that people can't keep up, but also moving fast enough that GraphQL doesn't lag behind and the new features that people are interested in eventually make their way in. So because we're always trying to make sure that we have that steady pace, most of what I'm about to say, if you've been reading about GraphQL, you will already know, which is the things that are coming up next are GraphQL subscriptions and the GraphQL Schema IDL. Both those two things are being used already by a lot of different people. And this is pretty common. It's something that I expect to see more of as GraphQL continues to advance, which is we start out with these rough ideas of things we want to add to GraphQL. We start to throw them through their paces by using them kind of as ad hoc add-ons used by one company at a time until we kind of rough through the things that work and don't work about them. And we gain some confidence, and then we start talking to each other about what it should look like in its final form, and then we start spreading that out across more people to test out the edge cases, and then we go through the final process of adding that to GraphQL formally. So GraphQL subscriptions is pretty far along on that path. We've been using it at Facebook for a couple of years now. I know the Apollo teams built pieces to be able to let people use GraphQL subscriptions in the open source community as well. And someone on our team, Rob Zhu, has been working on taking charge of all the people who are working on these things and pulling them together into final spec text to actually add to the spec. And so that's actually nearing its final state, which I'm really excited about, that we'll now have kind of spec compliant GraphQL subscriptions for everyone who's actually using GraphQL out there to agree upon and use. The IDL, which stands for Interface Definition Language, is another one of these things that we've been using now for over a year and still has some like last corner case issues to work out, but is also kind of at the very end stage of something that has a rough draft of spec text to be added to formal GraphQL and is just kind of going through its final pieces. For the few things that are at the beginning of that phase, where the rough ideas, they're starting to enter into the language or enter into the community to try to figure out what the right things are, and we don't know the answers to yet, are live queries. So what does it mean to say, here's the query that I care about, and I want that server to tell me if any part of that query changes, not just in response to a particular event. And I should be clear that we don't even know if this is a good idea or not yet. Like, this is like super early days for that idea. Another one that I'm particularly excited about is streaming responses for a GraphQL query. And so I gave a presentation on this last summer on defer and stream directives for letting you send a single query to the network, but then get it back in sort of like streamed chunks that eventually add up into a whole. And kind of this is a throwback to what we were talking, Jonas and I were talking about before, of eventually you get to the network and you realize that how you manage the network is just as important to your product as the data that you get back in the end as well. And so that's why it's really important for us to make sure that those tools aren't just available to you in the network, which you could build these kinds of things in either Apollo or Relay today, but they're actually in the product code that you express when you write your app. So those are also super early, that those might also turn out to be a bad idea, I'm not sure. And I'm always a little bit cautious when I talk about the things that are on the early side of GraphQL, because I don't want to create the idea that just because we're starting to talk about them means that there's an inevitability that they will end up in the GraphQL spec. We might find out somewhere along the path of investigating these things that they're actually a bad idea, or that they don't belong there, or something else. But I'm excited about all of those things. Those are those things on the early side. But to back up a bit and talk about what's next for GraphQL, long term, what we want to do is reach a point of stability. In the same way that today we're still using databases that talk SQL, and we're using more or less the same variant of SQL that we've been using for decades. That's my dream. That's what I want GraphQL to become, is to become the stable base that we can rely upon for a long-term foreseeable future in the networked data space within computing. What I don't want to see is GraphQL continuously having to reinvent itself every couple of years to stay on top of the latest pieces. My hope is that we have that stable base, but what we will be doing over the next few years is figuring out what the missing pieces are and continuing to evaluate whether or not we are actually on that right trajectory. I'm optimistic that we are, but that's the thing that we'll be looking at long term.
Awesome. Sashko, do you have anything to add to the future?
Yeah, I mean, I think that's exactly the right kind of stuff to be thinking about. One thing that I'm also really interested in addition to those things, which I think might not even be something that's like a GraphQL spec or something like that, is making GraphQL. I think when it just came out, it had some sort of reputation of being like a performance optimization or like something of that nature, where they're like, oh yeah, like I want to have better performance, but do I really need to like learn a query language? And I think most of what we've been doing for the last year and a half on the Apollo team is like fighting that perception that people have, because they're like, oh, a query language? Like, come on, guys. And I think taking that farther is one thing that I'm personally really excited about. I'm not even speaking for the team here. I don't even know if Jonas has heard me talk about this stuff a lot. But like, my dream is that GraphQL is this great way to describe data requirements, and take that to the like platonic ideal of like how you would want to build an app where you describe data requirements, right? Like even to the extent of like you write your UI components in, let's say, in isolation in like some sort of schema or component explorer. You put a GraphQL query or a fragment on there, and then as a UI developer, like you're done, right? Like you just have your schema, you got your UI components, and you just didn't do anything else at all. That's my like 100-year from now view of like development or something, which is like the entire data layer just disappears. And of course, like there's a lot of product considerations and exactly when requests are made and how the data is fetched and when it's normalized and pagination and all that kind of stuff. But I personally view a lot of those things as, in some sense, problems that can be solved eventually. Like if we find out the right, like people have been building apps for like 20 years or something now. I doubt that somebody 20 years from now is going to build some app that has some new type of data loading that nobody's ever seen before. So I feel like if you go through and you could figure out all the different ways that people want to deal with their data, GraphQL could become like the ultimate interface for doing that, and people would just like not have to worry about it anymore. That's all highly abstract, but like one really simple example is if it were easier to figure out what needs to be updated after a mutation. I think that's like the primary example of a feature in GraphQL, which people sometimes stumble upon, which isn't a problem at all with the spec or with the execution or anything like that. It's kind of like a consideration of like, it's almost like a theoretical problem. Like nobody really knows how to solve that concept of like, well, when you send a request to the server to update some data, like how do you know what changed? And maybe it's not something about GraphQL, but figuring out how that could be a little bit easier for people without like loss of generality or without performance issues is something that is always on my mind.
Awesome. Really great points. No, really great points. I think all of us on this show right now are betting on the future of GraphQL, and hopefully one day will be ubiquitous to many, new developers and more seasoned developers too. Unfortunately, that's all the time we have today on this show. Before we get into picks, first I want to thank every single one of you for being on the show. This is a new show. We're really trying to grow this thing and really make it successful, and all of you guys being here really helps do that. And everybody on this show, I think Lee, Jonas, and Sashko are going to be speaking at GraphQL Europe. And so we just want to give out a discount code for GraphQL Europe. You get 15% off, I believe. And the code is GraphQL Radio, all lowercase. So hopefully we will see you guys there. We may be doing a show there, who knows. But yeah, let's get into picks. Let's start with Joe.
I did not prepare one, but let's see. So during my parental leave, I bought the book called Types in Programming Languages. I've tried to read academic papers on type theory many times and always been really thrown off by the notation and not understanding what that meant. The book does a really great introduction to the kind of notation that's used in the papers, and also walking through like some simpler type theory, and that made all these academic papers like suddenly just make sense to me. And so, if you're kind of interested in that realm, I definitely recommend the book. It's even just like reading the first third of the book was really useful. So that's mine.
Awesome. Let's go to Lee.
So for those who have seen me do conference talks before, I always wear a bow tie, and I often get people coming up to me asking where I get all my cool bow ties. Well, I'm about to tell you. If you go to naughtyco.com, that's knaughtyco.com. They're based in San Francisco. I know the guy who makes them, and I have a zillion of them now, and they're super awesome. So if you want to look sharp, get a sweet bow tie, Naughtyco is the way to go.
Awesome. That's brilliant.
Wow.
All right, let's do Jonas.
All right. I also didn't prepare a pick, but so recently I've started to like play around with this website which is called viki.com, and it's basically a place where you can watch like Korean, Japanese, Chinese drama or TV series and shows. And they added a cool feature recently which basically gives you the subtitles and a translation, and you can kind of use that to learn the language. So I've been learning Chinese for a couple of years, and so I already had some level, and so I found it really super useful to watch TV shows where I can just keep watching and I'll understand like 75-80% of the stuff. But if I don't know something, or like I don't understand a word, or I'm not sure like what the exact translation is, I can just stop it and I can look at the translation right there, and that kind of helps me learn the language and the culture at the same time, which is really cool. So it's viki.com.
Nice.
Not a paid advertisement.
Yeah, we're not sponsored by them. But, if you're watching, I'm just kidding. Sashko?
All right, yeah, so I'm just going to go straight off the dome. You're going to see what I do in my spare time, which is I've discovered a new show by Gordon Ramsay, which is called Hotel Hell. So if you like shows such as Hell's Kitchen and Kitchen Nightmares, you're going to absolutely love Hotel Hell. And the best part about Hotel Hell is that all the problems are management problems. So as I've been leading the team here, I've learned a lot about bad hotel managers and how they could be better at inspiring their staff. So if you're a fan, definitely check that out, and all his other shows as well. I am definitely sponsored by Gordon Ramsay right now.
MasterChef Junior is my favorite Gordon Ramsay show. I just love, watching kids that are like 1/3 my age cook way better than I ever could. Love it.
Are you gonna start imitating Gordon Ramsay management style?
He's actually a really nice guy from what I've seen in the shows. I don't actually know.
Okay. Johannes?
Well, I actually didn't prepare anything.
No one did.
Well, what I'm really excited about is, but everybody's gonna know about that by the time the show airs. But yesterday, Airbnb released React Sketch App, which I think will have a massive impact on like the way how designers and developers can work with each other, what it means, like how you can keep your designs consistent, feed in real data. I also think that GraphQL will play a big role in that designers can work with real data. So there are actually a few examples up there in the Airbnb repository which already uses GraphQL. So I'm super excited about this.
Awesome, man. So I'm the only one who prepared picks, I guess. I have 2 picks. My first pick is all the videos from Apollo Day. Really, really good content for people who want to learn a little bit more about Apollo specifically. There's like good fireside chat, and I think Jonas has a great presentation as well. So please check that out. That's great. And my second pick is my company finally launched a full-featured GraphQL feature. Fully changed everything about our APIs, and we've bought all in now. But just to shout this out, it took a long time to convince everyone to do this, and I'm glad I finally did. So that's like my little pat on my own back, I guess. So yeah, thank you for tuning into the show today. Thanks everyone for being here. We'll see you next time. This is GraphQL Radio, the GraphQL podcast. Thank you.